deriving the equation of a parabola. This is sort of the long way of going about it. So I want you to imagine with me, and maybe go ahead and draw this really quickly. If the focus is at 0, -8 down here, that means that the directrix is going to be at y equals 8 up yonder. So the vertex is at 0, 0, and it's going to bend like this. But how do we know how it's going to bend? Well, imagine any point here. We're going to go ahead and say that that's at x, y. Now, its distance from here would be this distance here. And if you remember the formula for the distance between 2 points, that would be the square root of the difference between them squared. Well, it's 0 minus x squared plus, and that would be -8 minus y all squared. That's what that would be. And we want to know, when is that equal to this distance here? I know it doesn't look it, but it would have to be in order for this to work. So that point there would be, that would be at x, the same x, comma, comma 8. So when is the distance equal to the square root here, which is going to be the x minus x all squared plus 8 minus y all squared. Okay, so we want to know when these are equal. So let's get cracking. Lots to do here. So we're going to go ahead and turn this into the square root of -x, because 0 minus x is squared, plus, and then -8 minus y squared is going to be 64 minus plus 16y plus y squared. It's already getting to be messy. So 64 plus 64, you know what? Hold on. There's an easier way to start this. I'm going to square both sides because I don't want to write all those square root signs. Because if I square both sides, it should be okay because we're only working about the positive values. Normally, you have to worry about the positive, negative thing when you square both sides. Like maybe one of them is negative, but since they're both distances, they'd both better be positive. So that gets rid of your square roots, and that makes life a lot cleaner. So that's going to get 0 minus x all squared plus -8 minus y all squared. And what is that equal to? X minus x all squared plus 8 minus y all squared. Simplify where we can. 0 minus x is -x squared plus -8 minus y all squared equals, well, x minus x is 0, and 0 squared is 0, so we get 8 minus y all squared. So the -x times -x is x squared. And then if we square that out, I'm going to do that over here. -8 minus y times -8 minus y. I get plus 64 plus 8y plus 8y plus y squared equals, on the other side, 8 minus y all squared is 8 minus y times 8 minus y, which means you get 8 times 8 is 64, minus 8y minus 8y plus y squared. So we get 64 minus 8y minus 8y plus y squared. And now we can go ahead and start putting some stuff together. Like x, whoa, I did not want that. I do not want any of this. Stop. Okay, there we go. Got it. So x squared plus 64 plus 16y plus y squared equals 64 minus 16y plus y squared. So we're going to go ahead and take y squared from both sides. We can get x squared plus 64 plus 16y equals 64 minus 16y. Subtract 64 from both sides. There's room for me to work that on the bottom. There is not. Which means x squared plus 16y equals -16y. And now if we subtract 16y from both sides, because we want those y's to be on the other side here, because we want it to look like what we're used to, I hope you don't mind if I say that's negative 32y equals x squared. Now if we divide both sides by negative 32, you get y equals negative 1 over 32 x squared, which you'll notice if takes the form 1 over 4p, because if 4p equals negative 32, divide both sides by 4, p equals negative 8, which is exactly where we expected our focus to be. So life is good there. A little bit crazy. Just multiply it out and try to make it look like the equation that we started with. The cross-section with units and inches of a parabolic satellite dish can be modeled by the equation y equals 1 over 48x squared. How far is the receiver from the vertex of the cross-section? So here's what I'm imagining. Gray is a good color for a satellite dish. You've got this satellite dish. It's got this vertex where it's supposedly meeting some kind of a pole. Beaming math into space for reasons unknown. Modeled by the equation 1 over 48x squared, and the receiver from the vertex is actually going to be where your focus is. That's where you usually put the receivers there with the focus. Now remember, the form is 1 over 4p is equal to this part, 1 over 48. A move I'm not sure if you're aware is okay. As long as there's no zeros involved in the numerator or denominator, we can actually flip these to turn this into 4p equals 48. Divide both sides by 4, and I get p equals 48 divided by 4 is 12. So the focus is at 0, 12. That is the receiver. I always get receiver wrong on the I before E. That's right, I before E except after C. Don't tell anybody. Receiver is 12 inches from the vertex. Okay, some new ways to think about parabolas. That's all I've got for you here on parabolas. I hope you learned a bunch. If you have any questions, please email your instructor or send them a message. Until next time, this is Mr. P signing off, and I hope you have a wonderful rest of your day.